Instead of mugging reagents for reduction, understand this simple pattern. Hello students, let us start. Reagents for reduction, hydrogenation, under hydrogenation, complete hydrogenation. Alkane and complete hydrogenation gives alkane. Alkene and complete hydrogenation gives alkane. In presence of nickel, platinum, palladium along with hydrogen, at least palladium, platinum, nickel, complete reduction occurs. How? See here. Alkene and complete reduction in presence of H2 and any of these metals, syn addition occurs. Hydrogen is added from same side. If I take alkyne, same again, alkane gives alkane. So again syn addition occurs. Hydrogen is added from same side. If it is aldehyde, it gives alcohol. Ketone, it gives secondary alcohol. Acid chloride, it gives alcohol. Amine, cyanide, it gives amine. Isocyanide, it gives secondary amine. Epoxides, cyclic ethers will give primary alcohols. So these combination pattern, if you remember, any type of question easily can solve it. It is under complete hydrogenation category. Like acid, anhydride, ester, amide, no reaction in presence of this complete hydrogenation H2 or nickel. Because high temperature required, so normally no reaction. Partial hydrogenation up to some extent. Alkane is converted to alkene. But above what we got? Complete hydrogenation, alkane is converted to alkane. But here partial hydrogenation, just alkene stage, reaction stops. Which catalyst we use here? See. Lindlar's catalyst, H2, palladium and calcium carbonate poisoned with quinoline or lead acetate plus lead acetate. This entire mixture it is quinoline and lead acetate. So palladium and calcium carbonate along with hydrogen. It is Lindlar's catalyst. Simple modification if you do in place of CaCO3, if you use BaSO4, it becomes a Rosenmund's catalyst, RC. Lindlar's catalyst also syn addition occurs. Alkyne converted to cis alkene. If it is acid chloride, here Rosenmund catalyst we use for acid chloride. Here it is converted into aldehyde. Remember, nickel boride Ni2B is also used as Lindlar's catalyst. Same as Lindlar's catalyst. Nickel boride, how it is prepared? Ni2B, which is P2 catalyst, it is named as P2 catalyst if it is prepared from sodium borohydride plus nickel salt in alcoholic medium. Nickel boride prepared by using this particular reaction known as P1 catalyst. Nickel sodium borohydride plus nickel salt in aqueous medium, P1 catalyst. P1 catalyst, P2 catalyst, nickel boride also used same like Lindlar's catalyst, LC. Next, Birch reduction, sodium in liquid ammonia or lithium in liquid ammonia. Anyway, you can specify sodium in liquid ammonia or lithium in liquid ammonia. Here the source of H plus is ammonia. So important conversion, alkyne on Birch reduction, anti-addition of hydrogen occurs which will form trans-alkene. See all combinations I gave here. If it is non-terminal alkyne on Birch reduction gives trans-alkene. Hydrogen anti-addition occurs. If it is terminal alkyne where hydrogen is a terminal carbon which is acidic in nature. So Birch reduction, here it shows like acid base reaction type. The sodium, whatever sodium metal, react with acid hydrogen and forms salt plus hydrogen gas. If it is non-terminal alkyne, because alkene it is non-terminal alkene, here no reaction in presence of Birch reduction. If it is terminal alkene, here it converts into alkane. So different combinations you have to remember. If there is benzene ring, Birch reduction 1,4 addition is favored. So it gives product here like this 1,4 addition. If benzene ring having electron withdrawing group, exact the carbon where electron withdrawing group present known as ipso position. Ipso position, Birch reduction 1,4 addition occurs. So ipso position, so here see, ipso position this one. Same carbon, hydrogen reduced, hydrogen added and 1,4 addition. If there is ERG on benzene ring, then 2,5 addition occurs. For example, with respect to this, if you think what is 2,5, 1, 2, 3, or see from any side. For example, if I show in this side, see here. For example, if I give numbering 1, 2, 3, 4, 5, 6. 2,5 addition occurs in presence of ERG. In presence of EWG, hydrogen reduction occurs at carbon, that is ipso carbon. Ipso carbon is carbon to which EWG connected. Why it is so? See here reason. In presence of EWG in benzene ring, reduction occurs at ipso position, because at ipso position less electron density available. In presence of ERG, reduction occurs at ortho position. Reduction occurs at ortho position. Okay. Remember these two tricks to identify the product: 1,4 addition, 2,5 addition. Next, Bowell-Blank reduction, sodium in ethanol. Sodium gives electrons, ethanol gives H+. Aldehydes, ketones, acid halides, esters, cyanides. If allowed to react with sodium in ethanol, respective products: aldehyde give primary alcohol, ketone secondary alcohol, acid halide primary alcohol, ester alcohol, cyanides, amides respectively. Respective products I mentioned. Stephen's reduction, SnCl to HCl, were specially used for cyanide. When cyanides and Stephen reduction, partial reduction occurs, gives aldehyde. Clemmensen reduction, zinc mercury concentrate HCl. Strong acid presence reaction occurs. Carbonyl compounds on Clemmensen reduction gives alkanes. What's happening? Simply this group is converted to CH2, alkanes. Wolff-Kishner reduction, hydrazine in presence of strong base. Carbonyl compounds in presence of Wolff-Kishner reduction, alkane is formed. Same role, but your difference is, we'll see where we should not use this. Here it is converted to CH2. Here it is basic medium, here it is acidic medium. That's why Clemmensen reduction is not used if compound contains acid sensitive groups. Acid sensitive groups meaning basic groups like alcohols, alkenes, alkynes, ethers, acetals, ketols, diazo compounds and epoxides. If any such compound present in the compound, then we should not use this Clemmensen reduction, because Clemmensen reduction occurs in presence of strong acid. If any basic groups present, even these groups destroyed or react with that, so our main purpose dissolved, diluted. Similarly, Wolff-Kishner reduction is not used if base sensitive groups or acidic groups present in the compound like ester, acid chloride, anhydrides, amides, phenols, COOH. Reason, these groups will react with whatever basic group, basic this KOH. So we should not use. One example you see. I am taking here one ketone carbonyl compound with acetal group. Acetal group, see here structure acetal group. So acetal already we studied above, it is acid sensitive. So Wolff-Kishner reduction, acid sensitive meaning basic group. So acid sensitive group here. So Wolff-Kishner reduction, no problem. Directly it is converted into CH4. No other change, it is as it is. No change in acetal. But if it is used in Clemmensen reduction, yes, you will get. This is converted into CH2. But what's happening here, see, as it is acid sensitive group, in presence of Clemmensen reduction, first CO, this particular acetal is converted to aldehyde group. This acetal is converted to aldehyde group. Further on reduction, final product is this one as well as this one. Both are converted into CH3, CH2. So finally both CO are reduced. Difference you see. Wolff-Kishner reduction selectively reducing only CO. But here Clemmensen reduction, as it is acid sensitive group, destroying even ketol and converting into even CH3 step by step. Such cases, which is more preferred if they ask any question, you mention Wolff-Kishner reduction is more preferred if there is acid sensitive group is present. Okay, see, observe it now. See now, JEE Mains 2025 question. Identify the A, B, C in the following reaction sequence. Identify A, B, C in the following reaction sequence. So here we know what is this. Here it is Lindlar's catalyst. We know whenever there is Lindlar's catalyst, partial hydrogenation occurs. So here what we are going to get, after partial hydrogenation, we are going to get CH3, CH double bond, CH2. Partial hydrogenation. After this, whenever there is ozonolysis, which trick we use ozonolysis? Break the bond, add one oxygen on each side. It is reductive ozonolysis, zinc H2O. So you will get R CH3CHO plus HCHO. So A is this one, B is CH3CHO, C is HCHO, option 3. So Lindlar's catalyst should remember which convert alkyne into alkene, partial reduction occurs. Next, JEE Mains 2026 question, this year question. See here, butene and hydrogen 1 mole each are separately treated with palladium carbon and Na liquid ammonia to give the products X and Y respectively. So they gave different statements with respect to B, D, A, B, C, D. We need to find here first. So what we need to do here, first of all, but2-ine with Lindlar's catalyst. What do you get? Partial oxidation occurs, partial reduction occurs. So that too, what you will get here? Lindlar's catalyst, cis-but2-ene you will get. So here you will get syn addition occurs. Already we studied in previous, in this video. CH double bond, cis addition, the cis alkene observed. It is cis. If it is sodium in liquid ammonia, which is Birch reduction. Birch reduction will give trans alkene because anti addition occurs. So here see trans alkene. Trans alkene. They mention here it has X, here it has Y. Cis alkene, trans alkene. So now if you observe it, X and Y are stereoisomers. If you observe it, what they are asking, incorrect statements they are asking. X and Y are stereoisomers, yes. Cis and trans, these are stereoisomers only. Right? Stereoisomers. Dipole moment of X is 0. See, dipole moment of X, how it is 0? It is not equal to 0, right? It's a dipole moment of cis not equal to 0. By dipole moment of trans, it is equal to 0. So option B is incorrect. Boiling point of X is higher than Y. Boiling point of X is higher than Y. We know dipole moment directly proportional to boiling point. Dipole moment directly proportional to boiling point. Generally, mu net of here cis greater than trans. Dipole moment of X is higher than Y. That is also correct. X and Y react with O3, zinc and H2O to give different products. No, it is reductive ozonolysis. Whether cis or trans, what we do here? Break the bond, add OO, break the bond, add OO. Different products you will not get. Just according to trick, whatever we shall see. If you have any doubt in ozonolysis trick, you watch the oxidation reagent list video. There we studied with simple trick. So now overall if you see, incorrect statements, dipole moment of X is 0 incorrect. Because it is not equal to 0, cis is not equal to 0, trans is 0. X and Y react with O3 zinc to give different products, it is also incorrect. So B and D, option 1 is correct. Observe it. So overall, JEE 2026 questions, see how they asked Lindlar's catalyst and Birch reduction. Last year also they asked Lindlar's catalyst, very important. I hope all the questions clear to everyone. For more updates, follow the channel. Thank you. Thank you everyone.